Hello, my name is Mary Jo Fender and this is Math for Middle School. Today we're going to continue our work with exponents, and our goal today is to use a power to a power property and the power to a product property to simplify expressions that have integer exponents. What you'll need today is paper and pencil. Okay, take a few seconds to get ready to learn. In our first example, we're going to use our product of powers property to illustrate how to find powers of a power. Now in our first example, 6 to the 4th power to the 3rd power, you'll notice we have two exponents. I want you to focus on the exponent that is outside the parentheses, the 3. That tells us that our 6 to the 4th power is actually working as a base. And our product of powers says if we can expand that out, and it looks like this, 6 to the 4th power times 6 to the 4th power times 6 to the 4th power. And we have the same base, we simply have to add our exponents. So it would be 6 to the 4th plus 4 plus 4. 4 plus 4 plus 4 is 12. So our simplified version of 6 to the 4th to the 3rd would be 6 to the 12th. Now, using the product of powers property, can you see a shortcut for powers of a power? Is there another way we could get 6 to the 12th by looking at our original expression? If you said yes, hang on to that thought. Let's do another one and see if your guess works out for our second example. Our second example is 2 to the 3rd to the 5th. Now, if we expand that out, remember our 5 is going to tell us how many times to write our base. And our base is inside the parentheses, the 2 to the 3rd power. So in expanded form, it would be 2 to the 3rd times 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 2 to the 3rd. Now remember, product of a power, we can simply add our exponents if we have the same base. We have the same base of 2, so that would look like 2 to the power of 3 plus 3 plus 3 plus 3 plus 3. If you add all of those exponents together, you would get 2 to the 15th power. If you look back at our original expression, is there another way you could get 15? If you said yes, and you notice that 3 times 5 is 15, you have figured out how to use the power to a power property. The power to the power property says if we have a power to another power and it has the same base, which in case this does, we simply multiply our exponents to get our simplified form. Let's take a look at what that would actually look like in algebraic terms, in numbers, and in words. If you notice, our algebraic expression is a to the m to the n. We have the same base. You simply multiply m times n, and whatever that product is your new exponent. Sometimes it's a little bit easier to see in numbers. We have 5 to the 2nd power to the 3rd power. We're working with the same base, so simply multiply 2 times 3. 2 times 3 is 6. That is our simplified version, 5 to the 6th. Now in words, it's going to sound something like this. To find the power of a power, multiply the exponents. Let's take a look at another example. This time we're going to throw in a power of a product. You'll notice this time we have a coefficient of 2 in front of our variable power. So our base is actually 2 times a to the 2nd power. Now the 4 is going to tell us how many times we're going to multiply that particular factor, and how that would look would be something like this. 2 to the a to the 2nd times 2 to the a to the second times 2a to the second times 2a to the second. That gets kind of repetitive and hard to say, kind of like a tongue twister. If we expand that even further, we can actually see how the property is actually created. If we break it apart, notice we went from 4 terms to 8 terms, because when we have a coefficient in front of a variable, like it is in our example, that means to multiply. So when we break it apart, we're saying 2 times a to the second power times 2 times a to the second power times 2a to the second power times 2a to the second power. If I rely on some of my other properties, I can say commutative property allows me to group like bases together, like coefficients as well. So I'm going to move all my coefficients of 2 to the front, and I'm going to move all my variable powers to the back. Now when you notice that, I'm going to rewrite them as a power so I can use my power to a power property to simplify my variable power. Now you'll notice I have 4 2's, and another way to write that would be 2 to the 4th power. You'll notice I also have 4a to the second powers, so I would rewrite that as a to the second, don't forget your parentheses, to the 4th power. Now that's called the definition of powers. I'm just rewriting what I've known in expanded form as a power so I can use my other powers of exponents to simplify. Now 2 to the 4th power is 16. Now when we have a to the second to the 4th power, we're going to multiply the 2 and the 4 to get our 8. This is called the power of power property. When we are ready to write it in our final form, we're going to take the multiplication sign out, and it's going to look like this: 16a to the 8th. How it would look like as a power to a product property in algebra is going to look something like this. We're going to say a times b to the m. Notice the m is being applied to both the a and the b. In numbers, it's going to look similar to this: 2x to the 3rd to the 4th. The coefficient of 2 also has a power of 4. X to the 3rd also has a power of 4. So we're going to figure out the product of 2 to the 4th power, that happens to be 16. I'm going to use my power to a power property for x to the 3rd times 4. That's going to be x to the 12th. So my final simplified answer is going to be 16x to the 12th. Now how that sounds like what that sounds like in words is something like this: to find the power of a product, find the power of each factor and multiply. Let's take a look at another example. If I have 6x to the second power, you'll notice that my coefficient does not have an exponent. We need to remember that there's an imaginary 1 there. And when we apply the exponent of 2 that's outside the parentheses, we're going to say 6 to the second power times x to the second power to the second power. The explanation for that would be a power of a product property. We're going to then continue. I'm just going to bring down my 6 to the second power. I'll evaluate that in just a minute, but I want you to make sure you notice on the variable power I'm saying x to the second times 2. Our next line would be our evaluation of our 6 to the second power, and that would be 6 times 6. Now we're also going to do x to the second times 2, so that would be x to the 4th. So our simplified answer for 6x x to the second power would be 36x to the fourth. We have time for one more practice problem. Negative 2x to the fourth to the second power. Now, a couple of things I want you to notice. The 2 is a negative, so we're going to have to be careful when we apply our power of a product property that we make sure that negative 2 is in parentheses. So let's take a look at how that would look. So when I apply the power of a product property, I'm going to say negative 2 to the second power times x to the fourth times the second power. Each of my factors are now in parentheses. My power of a power property says I'm going to work with my variable power first. Because I have two exponents, I'm going to multiply those exponents together. So 4 times 2 is going to be 8. So my exponent on my x is going to be to the 8th power. I'm now ready to work with my negative 2. My negative 2 is to the second power, so that means negative 2 times negative 2, that is equal to 4. So my final simplified form is 4x to the 8th. That concludes our lesson for this week. I'd like to take a quick review with you. The two properties that we've learned today have been a power to a power property and a power to a product property. A power to a power property says to just simply multiply your exponents. Power to a product property says find the power of each factor and then multiply. I'd like to remind you to make sure that you practice your math this week so you can continue to improve. It's been my pleasure to have you in class today. My name is Mary Jo Fender, and I'll see you next week.